In these slides, we'll be talking about two topics that need special handling in collaborative filtering. The first is how to deal with implicit feedback. Remember that so far we have assumed the case where the user provides ratings to items, for example on a 5-star scale, or using thumbs up or down. These ratings are considered explicit feedback as users directly express their opinion, and it is the strongest signal we can have, but it is often rare. On the other hand, the system can collect feedback that is more abundant but may be weaker, and the challenge is to make recommendations based on such weaker signals. Implicit feedback is an umbrella term for all the things the system collects about user-to-item interactions. It may be consumption or purchase data. It could be other related actions like placing an object in the cart. It can also be clicks, page views, time spent on page. The challenge with recommending is that we don't know exactly what implicit feedback means. Is it a positive or a negative thing that the user saw a movie? Did she or he like it? Implicit feedback has typically a binary scale. 1 if there is a user-to-item interaction, and 0 else. It can also be on a count scale, for example the number of plays, clicks or purchases, or on a continuous scale measuring progress, for example how long was a song played for, how many episodes from a series were watched. In general, implicit feedback can be represented as a sparse interaction matrix similar to the ratings matrix. Zeros can be ignored. Let's see how we can interpret implicit feedback. What does a 1 or generally a non-zero value mean? Does the user actually like the item? Well, we don't know. As we said, implicit feedback is a weaker signal. The best we can do is assume that, or equivalently, we would like to predict these interactions. We can increase our confidence by slightly stronger signals like counts. If a user listens regularly to a song, she or he probably likes it. Okay, so what does a 0 mean? Does the user not like an item? Again, we don't know. As with ratings, the user might simply not be aware of the item. We can also make assumptions like treating 0 as negative feedback. So to summarize, 1 is typically considered positive feedback, while 0 may sometimes be considered as negative feedback. Memory-based collaborative filtering computes user or item similarities. In the case of implicit feedback, these similarities are computed using the interaction matrix rather than the ratings matrix. An important thing to notice is that mean centering does not make sense for implicit feedback data. Why? In that case, what would the mean indicate? Okay, but normalization is still important. It's just that we do it in other ways. One such way is to normalize along users. we require the user vectors, which are the rows of the interaction matrix, to have a unit norm. This is to discount feedback from users that provide lots of it. For example, heavy Netflix users. Also, when counts are used, it is typical to consider the logarithm of the count rather than the count itself. Why is that? Because, for example, a song that has 10 times more plays than another is not really 10 times better. So once you normalize the interaction matrix, say over users, playing cosine similarity works well. There are other proposed approaches that include non-symmetric similarity functions. The similarity of item X to Y is different to that of Y to X because it depends on which item was consumed first. This can be captured with estimating conditional probabilities, that is, how likely is to see Y given X, which is generally different than that of seeing X given Y. A final note concerns the formula for predicting the interaction of a user-item pair in the item-to-item case. The weighted average of ones is always 1. Why? Because the numerator and the denominator essentially sum up the weights. Note that this holds even if we normalize the interaction matrix along users. In that case, all interacted items of a user get the same normalized value, so all predicted interactions get that value as well. So instead of the weighted average, we can compute the average weight in the neighborhood, shown in this formula. We will now discuss the so-called cold start problems. These affect all types of collaborative filtering as they have to do with the sparsity of the ratings or interaction matrix. There are essentially 3 separate problems: new user, new item, and new system. Let's examine the case of a new user. This means that there is no feedback for this user. As a result, the new user has 0 similarity to all other users in user-to-user collaborative filtering. In the case of item-to-item collaborative filtering, there are no rated items, so we can compute no item similarities for the target user. Okay, so what can we do? So not much using collaborative filtering. We can make non-personalized recommendations based on popularity or user demographics if they are available. Moreover, as new ratings come, we can gradually learn using maybe only implicit feedback. Another option would be to try and have less cold users by eliciting their preferences, even asking them to rate a few items when registering. In another approach, social connections may be leveraged. If we know friends of a cold user, we may treat them as a user neighborhood and then apply user-to-user approaches. How about the case of a new item that has no history? Well, the item cannot complain if it's not recommended. So that's less of a problem. Still, we need to address this. If content is available, we can use content-based approaches that do not suffer from the cold start problem for items. Otherwise, we need to collect some feedback about the new item. So we should maybe expose it to random or some carefully selected users. For example, good candidates are users that are in general early adopters, are influencers, have a broad taste, and or are tolerant to potentially non-good recommendations. Once some feedback is available, standard collaborative filtering should work. The case of a new system brings the worst of the previous cases. Some ideas to handle this scenario would be to rely on external data sources. For example, to learn preferences for a domain by knowing preferences from another domain. Another approach is to use knowledge-based approaches that create a model of the world and map users and items into that. Such methods require no feedback. As always, once enough feedback is collected, collaborative filtering approaches can apply. The difficult question is to decide when you have enough data. Some ideas about these slides come from the Recommender Systems Specialization course in Coursera.